Syntax builds the form we see. Semantics gives it meanings key. Connectives link what minds devise. Quantifiers range through truth and lies. Modus ponens strikes with might. Modus tollens flips the fight. Logic cuts clean, no shallow line. Through the long night, reason shines.
Previously, we learned how to use truth tables to evaluate the truth value of a logical proposition. In this section, we introduce a special class of propositions whose truth value remains constant. A logical proposition is called a tautology if it always evaluates to true. It is called a contradiction if it always evaluates to false. Note that a proposition P and its negation, not P, always have opposite truth values. Therefore, if P is always true, then its negation, not P, is always false. In other words, the negation of a tautology is a contradiction and vice versa. Let us first look at a simple example. Intuitively, the proposition either the Golden State Warriors are the 2025 NBA champions or they are not sounds obviously reasonable, whereas the Golden State Warriors are the 2025 NBA champions and they are not sounds impossible. This intuition is correct. In general, given a logical proposition, P or not P is a tautology. On the other hand, P and not P is a contradiction. Both can be easily verified using a truth table. Sometimes one might be tempted to conclude that a logical proposition is a tautology or a contradiction based on intuition or experience. While such instincts can be helpful, we emphasize that the conclusion should only be drawn after carefully checking the truth table. For instance, consider the following proposition. If the Golden State Warriors are the 2025 NBA champions, then the Golden State Warriors are not the 2025 NBA champions. At first glance, this might sound highly counterintuitive, perhaps even ridiculous, and students may be quick to assume that it must be a contradiction. However, a careful look at the truth table reveals otherwise. This proposition takes the form if P, then not P, which is not always false. In fact, according to the definition of implication, such a statement is vacuously true when P is false. Hence, the proposition is not a contradiction. Next, let us study a slightly more complicated proposition. Let A, B, C be logical propositions. We show that the proposition A implies C or not A implies B is a tautology. Note that A is either true or false. In case A is false, A implies C will be vacuously true. In case A is true, not A implies B will be vacuously true. Since at least one component in the disjunction is true, the disjunction is always true, therefore a tautology. We finish this section with two more examples. Let PQ be two propositions. By checking the truth tables as usual, we can see that P and P implies Q together implies Q is a tautology. P implies Q is equivalent to not Q implies not P is a tautology. Note that for the above two tautologies, at the top level, the first involves a conditional connective, and the second involves a biconditional connective. Tautologies of these types are known as logical implication and logical equivalence, respectively. These tautologies are closely related to the rule of inference in the deduction process. We will explore them in more detail in the sections to come.
Shinla Tensei